My name is Dr. Priya Hasan, and I teach at Maulana Azad National Urdu University in India. And today I'll be talking to you about Numpy arrays and Pandas data frames. Now, both of these are fundamental data structures in Python for data manipulation, but there's a basic difference between Numpy and Pandas data frames. So we'll be talking about in more detail, which you'll actually see. But for example, one of the very basic differences is the Numpy arrays. The array has to be totally homogeneous in the sense all the elements have to be of the same data type. But a Pandas data frame allows you a heterogeneous type. For example, it typically represents two-dimensional tabular data, and in that each column can be of a different data type. For example, you could have names, for example, which are strings, and then ages, which are given to you differently, and things like that. And we'll see that depending upon the use, the requirement of your whatever your program is, depending on that, we actually choose and decide whether we work with Numpy arrays or with Pandas data frames. So let us first of all look off with Numpy arrays, and let's look at Numpy arrays. I hope you can see my screen. So what you see is Numpy is basically a short for numerical Python. It's a fundamental open source library which is used for scientific computing. And in principle, Pandas is actually it's built on Numpy. So Numpy is the more basic package, which actually does things. It's very efficient in storage manipulation of large multidimensional arrays and matrices. So here you can see, first of all, you have to import Numpy. I will share the GitHub page where you have all these notebooks, and you can actually use that to run these notebooks. Now, for example, I hope you've been actually told about lists, right? So let's say we define a list called 1, 2, 3. Right? It's a list because you have the square brackets. And from a list, I can actually generate a Numpy array. For example, here, I am saying array ARR is Numpy array of L. But if I say type L, it says it's list. Similarly, if I say type R, obviously it will call it a Numpy array, right? So the array which I've got is this array, which is exactly the same list, which is 1, 2, 3. Okay. Often we import Numpy as NP. That's what we generally do. So whenever we use things from there, you can say your Numpy array L, this is the one which is described. I can also describe another array, which is array 1, which is 1, 2, 3, for example. Please be careful about the syntax in this. What you can see in this thing is that when we are describing an array, we basically use round brackets, right? So you have the round bracket here, and then because there's a list, I have 1, 2, 3 sitting over here. So that's why I will write array 1 with the round brackets and then the square brackets with 1, 2, 3. Now, arrays are very similar to matrices. So for example, if I add array plus 1, okay, what it basically does is it adds 1 to every element of this array. Right? This often proves to be very useful in computations because, for example, if I have a whole set of data, I want to do this whole numerical thing for all the elements. In general, what would I have to do? I'd have to write a code which actually does it iteratively. It does it for every element from in column 1 to n or whatever. But here what happens is because I say plus 1, it does that by default to all the elements, right? So when I say plus 1, 1, 2, 3 becomes 2, 3, 4. If I say multiply by 2, so then what does it do? It makes 2, 3, 4, it multiplies each element by 2, gives me 2, 4, 6, right? So, it's giving me 2, 4, 6 for array 1. If I had done it with this, it would have done this with this thing. So this is 2, 4, 6 because it's multiplied it. Similarly, if I have one array and another array, L1 and L2, you can see what it actually does instead is it actually adds on these elements. So I have 1, 2, 3 and 2, 3, 4. On the other hand, if these were lists, it would have been differently. We can see. So the lists you can see are coming like this. But if I were to do the same thing, if I do the same thing, for example, with the arrays, for example, if I say array 1, okay, if I say array 1 and I say plus with array 2, what you now actually will get is you'll see individual elements are added on. So 1, 2, 3 is added to the second array which I had, which is 2, 3, 4, right? Whichever one I've mentioned it. Yeah. So it adds it like that. Over here in this case, I'm getting this because I'm still sticking to lists. In lists, it adds the list, right? I can also do various things like, for example, I can sum up. If I say array 1 sum, it basically takes all the elements of array 1, which is 1, 2, 3, and it adds it up, 1 plus 2 plus 3, and hence it gives me the answer 6. The important thing about NumPy arrays is about indexing. Indexing starts from 0, 1 to 3. So for example, if I look at array 1, element 0 is obviously 1, which is the first element. And then the second one is 2, 1, 3, etc. So if I take 2, I have 1, 2, 3. So like you can guess, this 2 will actually give me 3, right? So I can even print the whole array. I can do it like that. I can also define two-dimensional arrays, which are given to you as 1, 1, 1, 2, 1, 3, 2. For example, I can define this two-dimensional array. So if I look at the two-dimensional array, it's basically this. I can also, what's often done is you can generate random arrays. So I can generate a random array using the random task sits in NumPy. So I can say NumPy.random random, and I give whatever is the size of the array which I want, in which it has to generate the random elements. So for example, I have this one, which is 3 and 2. If I want to actually look at this thing, sorry, I will just put this with code cell. I can actually now look at what is my rand array, right? And I can see this is my random array, which I have of size 3, 2, right? I can also build up an array called zero array, which has zeros. And I can see it like this with whatever shape I want, and build my random array in 1 dimension, 2 dimension, whatever I want. Here you can see the one dimensional thing. I can also till whatever random arrays I can do. I can sum it up over a certain axis, right? So that will be you start off numbering your axes, and I can also get it in this way, right? So in this way, you can actually generate random arrays, okay? So I'm going to give you exercises, which would be the intention of it being slightly thought-provoking. So for example, here it is about creating a chessboard matrix. You want to create an 8 by 8 matrix, which has ones and zeros alternating. How would you actually do that? And then there's some more over here for which you may need to do a little bit of, a little bit of Googling, for example, random box simulation task. And I hope that when you do these exercises, it basically gives you a good insight into how to actually use NumPy arrays. The next thing which I'm going to jump on to is about Pandas. Okay, so Pandas is actually, it creates what are called data frames. Okay, that is what you have in Pandas. You use data frames. And what's good about these data frames is this is very good for data manipulation. For example, you could sort data, you could filter data, reduce data, access process, right? So that's the advantage of it. So for example, here we already have a data frame. I will provide it to you. I can import it as PD. So that's the standard way to import Pandas data frame. And here I'm actually defining a data frame. Okay. And you can define it from a list. For example, I have a list 1, 2, 3, 4. I can define a data frame from that. So this is printing my data frame, which is coming up over here. I could also define a data frame like this. Now, this is the interesting part. In data frames, for example, this column you can see is a string, and here I have numbers, and I can have various things like that. And therefore, for example, in Pandas data frames, the indexing is not as simple as it is in NumPy arrays. You use something called iloc, and basically that is the location, because we don't have, they're not all same data type, and hence the location is important. You need to know the location. Accordingly, you can look for it. So you can have these various data frames. For example, this data frame, you see this is over here. Then these are your indexes, your columns, etc. So you can have all these kind of things. Here there's another data frame which has the names, maybe age or whatever it is. So it's named with age. And you could have it like this. And this proves to be very helpful when you're doing data analysis. So here I'm going to basically show you a data set, which is m3.csv, which is a cluster called m3. And this is basically Gaia data. And this is in CSV format. So I'm importing this, and you can look at this data frame. It basically has list of 36,000 stars over here, 36,424 stars, which is the RA, deck, parallax, proper motion in RA, proper motion in deck. Okay. This last column is radial velocity. You'll see many of them are not available. For some of them, it's there. So looking this, you can look at the data frame which we are getting in. So you can, for example, use various things to, I should have actually corrected this. I'm going to install this package has become obsolete. So therefore, we are going to do pip install Y data profiling. That's another thing of doing it. And from Y data profiling, this is similar to Pandas profiling. It's exactly the same thing. You can generate what is called a profile report. Okay. What is important about a profile report? Let me run it again. Is here, let me see, we are making a report. So here, the first important thing which you do with data is you characterize your data. You study the data. So when you get a profile report, what it basically gives you, it gives you all kinds of detail about the data you are trying to analyze. For example, here it tells you the number of variables, this tells you the number of columns, we said 36,424, number of missing cells, what is the percentage of missing cells, what are the duplicate rows, total size in memory, various data sets. And then for each column, it's actually going to give you data. For example, for array, it's telling you have so many distinct arrays, and there's 0 missing arrays, and this is the distribution. For example, dec is actually declination. And declination, again, we have all of them with 0 missing values. If you have parallax, you can see you have so many missing values. And this is the kind of distribution, the minimum, the maximum, the zeros, etc. You can see the distribution, proper motion array. And often this is a very important exercise to do because first of all, you need to know what is your data like, right? You can actually look for interactions, correlations. Correlation, this is a heat map where you're actually looking at the relation of one without the other. And in principle, there's no relation of one with the other. You can see one is only by itself. RA to RA is obviously one. But the other ones, you can see there is in principle no correlation because these factors don't obviously depend on each other. You could also see in the form of a table. You can also see the missing values, the heat map of the missing values, the matrix, etc. And you can actually have a look. So here's our sample. So here you can see, I can see the type of data frame. I can see a particular column. What kind? This is a Pandas series data. I can even look at parallax, for example, check things about it. We can look at the head. This is the 8 first rows of the data set, data frame which we have. I could drop the ones which have this kilometers per second because this is radial velocity. They are missing data. So I just drop the columns with them because many of them are missing. And I can actually look at the head and the tail. I can even describe the data set, which will actually give me the description. Now, you can do various manipulations with this. For example, you could make a list of columns, which is only a specific list. You could have the lock, which is specifically the rows which are 6, 7, and 14, which are listed over here. I could also take it in terms of only the certain columns, RA and DEC. I can also do various things. For example, I can have masks on them. I can also, for example, I'm looking for only coordinates, which is series this thing, and I can get the coordinates over here, for example. I will run through this because we are running low on time, but I'm sure you can run these things and actually see. For example, PMRA, I want a histogram plot. I can look at the distribution. I can plot here RA versus DEC. So Pandas data frames actually prove to be very, very useful when you are actually trying to manipulate data. I've also given you a set of exercises to follow, and I hope you can try it out and get back to me on Discord if you have any questions, and wishing you all the best. Try it out and let's see.